Alright guys, so in this video we will be covering the CI/CD using Azure DevOps. So you already know, right, we have been following this microservices series, and so far we have covered deploying Kubernetes and deploying VPN, virtual network, etc, etc. So in this video, particularly this video will majorly revolve around deploying the CI/CD pipeline using Azure DevOps. Alright, so let's go back to our diagram and revisit our architecture. So you know, right, we have already deployed this virtual gateway, we have already deployed this cloud, and we have already deployed this Kubernetes cluster. Today we will be deploying this major part, this one, right? So we have GitHub here, we have Azure DevOps here, and then we have a self-hosted agent here. And using all these three, combination of all these three, also along with Helm, we will try to deploy our application into this cluster, right? So this is the activity practice we will be doing, particularly in this video. All right, so let's go to the diagram first. Let's try understanding the concepts. All right, so before going into deep and try deploying all the CI/CD pipeline, let's quickly talk about why do we need CI/CD pipeline, right, today in today's world. I don't know if you remember, initially in some of my videos, I tried discussing about the concept of agile when I was talking about the microservices. So in that video, I explained you that this world is going very fast in terms of business requirements, right? If one company disrupts with the one beautiful product, another competitor company, they also try to come into the market with the same product. Right, so that's where the requirement and everything comes in, all the changes, right? So changes is kind of constant in this world, and we will have to come up with a way so that we can adapt these changes very fast in our IT services operations, right? As I said, IT services operations are basically serves the different domains of the industry. Right, so IT is not a domain where all the operations comes in, but IT is something that serves another industries, right? So I don't know if you talk about recession, right? Do you understand why did recession, the IT impacted because of recession of 2008, also the recession of COVID? So because IT has nothing to do with it, right? IT is dependent on other business industries. Now, because of the fact other business industries have been impacted, IT will also be impacted. All right, and that is where the IT company has to cut off all the budgets for salaries and have to lay off multiple employees because of the fact that the billing for let's say there is a project X, and this project X is being served for a Nike company, let's say shoe factory, a shoe company. Now, shoe company also have an X budget, right, for its IT operations. Now they have to cut that budget by some amount, and all the billing operations for the IT operation will also get impacted. That's where the whole IT and everything, that's why we impacted. But this video is not about the recession, so let's directly come to the point, CI/CD. So in order to adapt all those changes very faster in today's world, we need some kind of methodology in IT, so everything can be aligned so easily in just few days, right? So this is where the concept of agile comes in. Agile means very fast. So things are changing very fast. Now what I'll do, rather than having a big amount of days to deliver my business values in terms of softwares, what I'll do, I'll have a couple of days, let's say 10 days sprint. So this is where a sprint comes in, right? Do you know a sprint, the runway, right? A runway of 800 meters, a runway of 100 meter, it's called a sprint. So you basically you run very faster to complete that 100 meter, and then you basically finish 100 meter, and that's it. So this is where the concept of sprint comes in. So sprint, let's say you will take a work for 10 days, and then for the work of 10 days, you will make all those code changes in the features and try that business value in terms of your features, in terms of your code, to the product owner. Now product owner will be someone who will basically verify if all the changes that you have done are aligning with the requirement of actual business or not, right? So that's the concept of sprint. That's also the concept of Scrum methodology. That's a fancy concept today we have been following in day in, day out in our organizations. So now, if you are following agile, right, and you have a team of, let's say, 5 or 7 developers, and if your developers keep wasting their time, so basically developers have some limited bandwidth, right? If you are following a 10-day sprint, that means a developer have to also engage in the meetings, they will also have to code, they will also have to understand all those things, etc, etc, right? Now, if my developer is coding and implementing a feature or making changes in the feature or doing some etc work, also along with this, if he or she the developer invest his or her time to deploy the outcome of all the code, everything that the developer has done so far, deploy it manually to the environment and deliver it to the QA for further verification, all these things will take some time, right? And the concept of agile will start breaking. Now, in order to fulfill this, we need to have a way where my developer will only code, commit it, and that's it. Everything will be inline and will be automatically, all the deployment, verifications, container image creation, my QA test run, everything will be in place and will be automatically done for the code that a developer has basically checked in the main branch. Now, in order to do that, so in today's market, that's why the DevOps came in, and DevOps said, okay, we will basically set up a pipeline. So that pipeline will kick off from the very first moment, the moment when the developer commits his change to the main branch. When I say, you already have a repository for your particular code, right? So for example, if you see, this is my GitHub, right? So GitHub is acting as a source code repository. So source code repository means this, I've been organizing my code in a particular repository. So it's basically keep being tracked under all the changes and everything. Now, and then every repository in a GitHub or Bitbucket, whatever you are using, has a main branch or a master branch, right? People call it master or main, doesn't matter, but it's a main branch, important one. So the moment he checks in the code in the main branch, your pipeline will get triggered and all those activities will start performing automatically, because you have already defined those set of activities that the moment the developer will commit the code, all these things will happen. All right. So now we will have to see how can we implement this CI/CD, right? So first we will draw the architecture and then we will try to implement that architecture using Azure. Now remember, fundamentals will never change. Fundamentals are still same. The only thing will change is today we are using Azure. Maybe you are working on AWS. Maybe some other guy is working on GCP. Maybe you are not even working on cloud. You are working on-prem. Then you might have a different kind of VMs and all those things. But the concept, the core concept and the fundamental will remain same. All right. So let's start drawing. So let's say, let's think this is the ecosystem. This is the overall ecosystem of our CI/CD pipeline. All right. Now in this CI/CD pipeline, the first thing that we need will be the GitHub. All right. So let's say this is my GitHub. Okay. And also the important one, we actually left it out. User, the developer. All right. So this is my developer. Let's pick this one. So this is my developer. My developer will checks in a code. All right. So my developer will merge in main. All right. Now this guy, the repository has a YML file. Let's call it a pipeline file in YAML format. All right. Now we will see, okay, how, from where are we getting this pipeline file, this YML file, right? This will get differ from systems to system. For Azure, they call it Azure-pipelines.yml. Maybe some other organization will be using something else. Now, the moment you merge your code into GitHub repository main branch, so there will be a build get triggered in the Azure DevOps. So what we need, we will create another subsystem here. All right. Now you call this pipeline is this is your Azure DevOps pipeline. All right. Now remember, this repository has Helm packages as well. Now understand what is Helm. All right. Now you have Kubernetes. In my last video, we already spoke about Kubernetes. What is Kubernetes? Why do we need Kubernetes? In case you need a separate video for Kubernetes, just comment Kubernetes. I'll start making a video on Kubernetes. Now, so Kubernetes is acting as a orchestration platform for orchestrating the Docker containers. All right. So I need a packaging framework to package my containers and deploy it and ship it to my Kubernetes cluster. And this is where the Helm comes in. remember, Helm is not the only way you can ship your containers and package your containers to Kubernetes. You can use manifest files. In fact, when you use Helm, indirectly you also create deploy.yml, service.yml, hp.yml, all those things. All right. So now assume this guy has your pipeline. Also, this guy has. Let me write it. Otherwise, you guys will be a little confused. This guy has business source code. All right, and this guy also has your Helm charts. All right, in case you need an understanding of Helm chart, you can just comment Helm chart. I'll create another separate video on Helm chart. All right, but anyways, we will go through the Helm charts specifics in this video as well. So this video will be a little bit longer than usual, around 1 hour. So just hold your horses for some time. Okay, so this GitHub has all these codes in terms of your Helm charts, source code, and your pipeline file. Now this guy, the moment this pipeline will get triggered, all right, I don't know why this line is not visible here, but anyways, just understand that this line, this build will get triggered here. That's, I'll color it, Azure pipeline. All right, now set of activities will start happening as part of pipeline. Now the overall outcome of this pipeline will be a Docker image. So this Docker image will be saved in my Docker container registry. Now where will I get this container registry? In your Azure, you already have Docker container registry. So after this architecture, when I'll relate this architecture to the actual Azure cloud, you will get an idea. So just hold for some time. All right, so this is your Azure. I will write it down for your understanding. So this is your container registry. All right, so this guy will save a Docker image where? Here. All right, so this will be my Docker image. All right, now Docker image for service, for a particular service, for it will be a service, right? Let's say you are writing a product service, you are writing a user service or XYZ service, so eventually it will be a service. So now this guy, the outcome of this guy will be a Docker image, will eventually be stored in a container registry. Now from this container registry, once it is done, right, the successful completion of my pipeline will lead to the initiation of my release pipeline, right? So these are two different pipelines. In my last video, I said many people, what the practice they follow is they combine the build part and the deployment in the same pipeline. Many people, many different organizations, they follow a different practice where they keep their build pipeline separately from the release pipeline. So release pipeline is where you keep managing your releases differently. All right, so I will write another box here and I will say my release pipeline. All right, so I'll make this blue. All right, so now this guy, once successful, so I'll go here and I'll write it after post success. All right, now release guy, the actual job of release guy is to use the Helm commands and deploy it to the Kubernetes cluster. Now what I'll do is I'll make it shorter a little and then I will expand this. I'll create another subsystem and I will say that this is my Kubernetes. This is my Kubernetes. All right, now this guy will use some Helm commands and deploy it to the Kubernetes cluster. All right, so I'll write it down. This is my Azure Kubernetes service. All right, so now in my last video, I spoke about namespaces, the logical separation inside the cluster you could have using namespaces, right? So I'll create namespaces. So let's say I have different namespaces. So for some, for just for understanding, assume that the name of this namespace is retail dev. That's how I have organized my namespace in Kubernetes cluster. All right. And then this guy also has an ingress. So I'll basically use the pod here. Okay. So I'll copy this, I'll remove this, and I'll say this is my ingress pod. So ingress is a special pod special service, which basically does all the rerouting here and there over all the APIs that you have deployed in the pods using your business services. All right, so I will name it as my ingress. I could have drawn this diagram before making this video as well, but I wanted you guys to go through this diagram and understand each aspects of it, right? So I understand that this will take some time, a little more than usual, but that is how you can understand the things properly. All right, so this is your ingress. Now this guy will deploy to Kubernetes, and the moment it deploys to Kubernetes, there will be a pod will get created, right? So let's say you are doing everything for user service, because I have created sample application in Java. So that sample application, the name of this sample application is user service. So I will draw this IO here, and I'll say, and I will write it as deploy using helm, and then I will say what will happen, pod will be created. Now the moment pod will be created, there will be three things that will be created, 3 or 4 things. Let's say deployment YML, service YML, and its ingress and HPA. All right, also now this pod, the user service, is talking to my database. So where is my database? The way I have organized is this user service specifically talking to Postgres database. All right, so I'll create a database here, and then so this database is here. All right, now this data, how this pod is talking to database is using a connection. All right, now this database has some username and passwords. So these username and passwords are not being stored inside this pod, right? So the way it has been organized is I have created secret. Using that secret, this pod is taking all the values of username and password. So what I'll do is I'll create a secret. So I will create a secret here. Although it's not a pod, right? It's just a small secret somewhere in the Kubernetes. So I'll say database secret. So secret basically has for base 64 encoded values. So this guy is taking values from here. All right, and I'll move it to here, and this guy is talking to my database. All right, so this user service will be talking to this Postgres database. All right, now here if you see, I have also written ingress. The moment it will get deployed, its ingress will also be created. So this API will be exposed, whatever API is right here will be exposed via ingress. So this also has a public IP address. All right, so I'll say, let's say it also has a public IP. Okay, now this developer now can use Postman. Let's say this is Postman for Postman client for APIs, right? Now this guy can use Postman in order to access these APIs. All right, so this is the entire setup. That's how the things will work as part of the CI/CD using Azure DevOps and Kubernetes. So this was the architecture overview, a kind of 5,000 overfeet overview. So let's deep dive into the actual deployment. All right, so I will save this. Now let's go one by one and see one by one. Okay, all right, so let's go see. For a moment, assume I'm a developer, I'm an actor, right? I'm an actor. Now this GitHub, I already have this GitHub right here, right? So I'll duplicate this. I'll go to my main and I'll say user service. So I have this code here in my user service. This is my GitHub. All right, this guy is right here. Okay. Now let me open this in IntelliJ. Okay, now you see this service has some kind of Java code, to some kind of business logic, a very vague business logic I have written, whatever I've written, right? So this has user control. You can create services in Node.js, Python as well, and in the upcoming videos I'll be creating most of the videos using Python and Node.js, right? So this guy has this user controller which starts with v1 and has these two APIs, post API and get API. Using post API, it's creating, right? And then using get API, it's trying to get the data by getting IDs of the users, right? So you will have to pass the ID as part of the API, as part of the query parameters, and then this API will go to database, will get all the records from the database. So you see I've written this repository. All right, this repository. So now, and also this has some DB migration files. I've used Flyway for the database migration. However, this video is not talking about the migration, so I'll not talk much about the database migration. I can create another separate video in case you want. So, and then the same thing happens, create API, basically creating all the user in the database. All right, so this is the basic, this has service, right? Service and the user repository, etc., etc. All those traditional things you already know about it, right? But if you, in case you are watching this video, I assume that you already understand all those things. Okay, so now let's move on to Helm. Now, yeah, before moving to Helm, let's talk about Dockerfile. So as I said in my last video, right, rather than have to maintain 20 different dependencies to deploy a business service, it's better to have a container, deploy everything inside it and ship that container to the orchestration platform, which is Kubernetes, right? So in order to create a Docker container, you need a Docker image, and in order to create a Docker image, you need a Docker file. So what I'm indicating is the content of Docker file, which has the first point. If you see, I have used from OpenJDK 17. So I'm asking my Docker file to go and download the OpenJDK 17 version inside this container. And I'm saying that, okay, whatever the result, whatever the file which is inside .jar, which is inside .library, .libs, right, inside this file, which will be my eventually a jar file, right, the compiled jar file, which will be acting as a main run package, right? Copy that into my Docker container and rename it to the app.jar. Very simple. And once you do that, once you finish doing that, all those two above points, you basically do a command java-jar and run this app jar. So when you will run java-jar, that means the service will get up. So first it will create a container, download the JDK image, copy the jar file inside it, and the container will get up. The jar file, your service, the actual Java service will get up. So whatever port you are using, so if you go back to my source file, go to main, go to resources, go to my application file. This is my configuration file. So I'm using server port 6061. So the moment this Java service will get up, it will start listening at port number 6061. Okay. Now, so this was the basic theory around the business logic and the Docker file. Now let's deep dive into the Helm. All right. So I've created this Helm folder. So this is the Helm chart for my user service. If you go inside templates, there are multiple templates. So this is deployment.yml. You will see all these jargons here, right? So you don't have to worry about it because Helm automatically creates. But remember, these are generic templates. So you see this values.image.pull policy. That means this value will come from the values.yml. So we will have to maintain values.yml. Then there is hpa.yml. So the main agenda of hpa.yml is the horizontal port scaler. So let's say your pod is running inside Kubernetes. Now you have to define a threshold limit. Let's say you have defined, if my CPU goes beyond 75% of utilization, you start scaling my service till n replicas, in max n replicas. All right, and if the threshold is less than 75%, CPU utilization less than 75%, you don't scale it. You only basically maintain one single replica. So that's how you are saving the overall cost, right? Because your resources will be minimally used. So now, so this is the main agenda for hpa.yml. Alright, then you have ingress. So ingress does nothing but it creates an ingress for the service, right? In the Nginx, the ingress part that you created in the beginning, right? If you go back to your architecture, you will see that this is the ingress that I have created. So also I have written here, right? It will create an ingress. And then it will also create a service.yml. Alright, so that means you already have a deployment in place, you already have an ingress, but your service is still not exposed. So in order to expose all these services, you need a service. So this is where you are creating a service.yml. All right. So let's not talk about service account.yml. We don't have to worry about it. I'll go to values.yml. You see all the generic values are right here. Now the way it works is, in my Kubernetes cluster, if I'm working on a local development, so I might have a dedicated namespace dedicated for your development environment. I might have a different namespace for QA environment and different for integration environment. If you are working in a big enterprise organization, they might have different clusters. If you are basically using a cost optimization strategy and you want to efficiently use your resources, you not created a separate cluster for QA and integration. You have combined everything into one single cluster and you have segregated logically all these environments in terms of namespaces. So you have one namespace dedicated for dev, one for QA and one for integration. All right, so let's say I have to deploy this user service into a development environment. So what I'll do, I will simply refer my values-dev.yml for my deployment in the dev URL environment. Sorry. Now there could be case that I might not need a property in development environment, but I need that property in QA environment, or there is a property which will vary environment to environment. So what I could do, I could create multiple values.yml here. So if you want, what I could do is I can create, let's say, values.qa.yml. But the moment I will deploy, I will make sure that in my QA environment, this values.yml needs to be referred, right? But currently I'm referring this values.dev.yml. So that's the main concept that we have, the reason we have this values.yml. So if you go to values.yml, I have set replica count, keep replica count equal to 1. Now see image policy. All right. So image policy, image repository is the repository where I'm keeping my Docker images in Azure. So the container registry, remember in the architecture, if you go back to the architecture, I have written this container registry. So the address of this container registry will come right here, this. So I'm basically commanding this guy to go look up at this Docker container registry, go inside Urban Images and go inside user services. You will find my Docker image, the Docker image I want to deploy here. All right. And the tag, the version of Docker image will be the build ID. We'll see what is build ID. All right, let's move on. Service, I'm saying let's not create a load balancer type of service. Let's create a cluster IP. So my cluster IP will be one of the IP will be inside my cluster. However, this service will not be directly exposed outside, right? This guy will not have a public address. And these are the ingress related details. I'm saying, okay, just create and just use nginx, which is, so where nginx is written. Interestingly, let's see where nginx, inside this part, nginx is running, right? Inside this guy, nginx is running. So nginx is acting as a load balancer kind of here, a proxy. Understand, let's say proxy. Load balancer will be a different terminology. So let's understand it's running as a proxy. Now go back. Now what I'm saying, class name, many people use application gateway as app gateway as well. So the way it will work, if you assign a class name as application gateway, your ham will see application gateway, your Azure will automatically provision an API gateway inside Azure. But however, we are not using it because that's a costly resource. We don't have to use it. So we will manage with the nginx, which is a pretty much good resource, I think personally. Now this is another interesting term. What I'm saying, I'll try to understand. First of all, let's understand these things. I'm saying, okay, when you will deploy it, and the host will be this URL. So if my request come to this URL, and after this URL, you will have to, means my service my APIs of my service will be found after this host, after this hyphen user service, right? And then I can use whatever my path I want to pass after this user service, right? So this $2 defines your path. It will basically come right here, right? So I'll quickly explain you. If you go and if you see, let's say, yeah, I'll paste it. Yeah. So let's say this will be my host. All right. If I want to access this API, I will use this as host, which is HTTP only, not HTTPS. Go inside user service. That's why I said, right? Go inside user service and whatever I pass here, you append it after user hyphen service. So this guy, all these things will be appended right here after this. That is why we have used all these asterisk and everything. All right. So these things will be passed right here. Now, so this is the concept of ingress, and this is the concept of $2. All right. Resources, I have not allocated customized resources to user service. However, I can, and the best practice is you should always. Auto scaling, I'm saying minimum should be 1 and max should be 10 replicas. So see, minimum replica, there will be one instance, right? Understand this diagram, there will be one pod. So when I say replica, that will be one single instance pod, this one pod. Now CPU utilization goes beyond 80%. If you see, the CPU utilization goes beyond 80%. So there will be 2 pods. Another 80%, 3 pod, 4 pod. Till how many? Till 10 pods, max 10 pods. If you see, the max pods is 10 pods. So that's how you are scaling and descaling, right? Based on your load. So that's the concept of horizontal scaling. I don't know if you have watched my first video, right? So where I have explained the vertical scaling and the horizontal scaling. All right, so this was the basic overview of your user service, your business code, your Docker file, also your Helm packages. Now let's move on. So let's have a look at, okay, we understood this. Now let's have a look at Azure DevOps pipeline. First, have a look at container registry, because we have already spoken about it. Now, if I go back here, I will say container registry. Sorry, I'll say just registry. Container registries here. See, this detail solution one, if you see, I am using this path, right? Detail solution one. All right, so if you go here in the repositories, you will see urban images and user service. All right, you see urban images and user service. All right, all these versions right here, all these texts are right here. And if you go in one of the folder, you will see that that's how it will use a Docker pull command. Docker, this is your usual Docker pull command. It's not, we are not pulling it from the Docker hub, rather we already have our custom container registry. We are pulling it from our registry. Okay, now, so we've gone through container registry. Now let's go through the most interesting part, which is Azure DevOps. All right, so I have already created my project in the Azure DevOps, my organization in the Azure DevOps. So this is my project, Associate Consulting. Inside it, I have multiple pipelines. You don't have to worry about all pipelines. All right, so now what I'll do, I'll go inside my user service only. Okay. Now, the moment you will create it, let's say if you want to create one pipeline, how will you create it? You have to go a new pipeline. Which pipeline? Okay, my source code repository is at Git. So I'll go to Git. Now, since I have already created a service connection with it, right? Now, how can you see where the service connection? In my last video, I said when you connect your GitHub with your Azure, or when you connect your Bitbucket to your Azure, it automatically creates a service connection to access all the code, whatever exists in your repository in the Azure. Now, if you go to project, right, and if you go to settings, not settings, service connections. You see, I already have these multiple GitHub service connections already, right? If I want, I can create a new one, right? It depends. So now I'll go back to my pipeline. And then I can create a new pipeline. Also, I'll go to GitHub. And then if I want to create a pipeline, let's say user service, I'll select it. It will automatically give you some recommendations. Okay, what do you want to do? You want to create and Docker. So what I want to do is build and push an image to Azure Container Registry. I'll select it. It will give me some of few of the options, right? So I'll select, this is my Azure subscriptions, and it will say all those things will start happening. So I will not do these things. I'll directly come to the point where it will reach after doing all these steps, right? So I'll go here. Yeah, when I'll edit. So you see, inside this GitHub, I have this Azure-pipelines. So when you're done doing all those steps that I did earlier, some time back, once after finishing all those things, Azure will automatically commit one file to your repository. So that means your repository has pipeline YML now. If you remember, I said your pipeline, your Git repo will have a pipeline file, right? So that's the pipeline file. This is the pipeline file. This is the pipeline file. So I will not read from here. I'll go to my IntelliJ and I'll show you. So this has my Azure-pipeline. So in my pipeline, what I'm doing is I'm asking, first of all, I'm saying pool name, very important. What is this pool name? Understand. I'm asking, so in my last video, I explained you that there are, all right guys, so if you see in this, I was talking about pool, consulting pool, right? So in my last video, I explained you there are two types of pool in my Azure, right? So one is the Microsoft hosted pool. Second is my self-hosted pool. So in the real-time organizations, we don't use Microsoft hosted, although you can if you are a startup or you are a small, if you're doing a personal project, because Microsoft is managing all those pools, right? Agents. But I need my dedicated agents for all the DevOps work. So what I do is I'll create my self-hosted. If you want to understand the self-hosted, the main concept around the self-hosted pool and how to implement it, deploy it to the Azure, please check out to my different video that I have created yesterday. Now this consulting pool is my self-hosted pool. All right. So there is one dedicated agent which will basically does all this task. Now in the steps, you see, I have defined first Gradle task. What I'm asking is use this tool and as part of first step, do a Gradle clean build. So when you will do a clean build, what will happen? It will create this kind of directory, right? A build directory. All right. Once you do that, once you finish doing that, you do a Docker task. And what you will do in Docker task, you create the Docker image using Docker file. Where is my Docker file? In my sources. This is my source. This is my source. All right. This is my source. Now using this source, inside the source, I have Docker file. Use this Docker file and create a Docker image. That's what I'm asking. Once you do that, and when you create a Docker image, use this tagging number, whatever my builder number is. A build number, this is specific to Azure DevOps pipeline. All right. You just Google this build number, you will get an idea. But you can assign any number. However, I'm using this build number, which is kind of more professional and organized. Once you do that, push that image to a Docker container registry. And where is my container registry? Retail solution.01 here, right here. This container registry and this container registry. All right. And then once you do that, that's it. You drop publish this artifact to somewhere in your DevOps. All right. However, we don't need this. You can probably remove this as well. The important part are these two. All right. Now this is your DevOps explanation, the definition of your Azure pipeline.yml. Now if you go back and see, along with this Azure DevOps pipeline, we also have a release pipeline. Sometime back I said release pipeline is to manage the releases, right? This is only dedicated to build the Docker images and containers and put it inside the Docker registry. And this guy is specifically dedicated to manage the releases. All right. So now what I'll do is I'll go back and I'll go to releases. So these are pipelines and these are my release pipelines. I'll go to release pipeline. All right. Now you see, this is the user service deployment pipeline I have already created. When you will create it, Azure will not commit any kind of file to your Azure repository. You just simply will create a release pipeline right here. So if you go and click on edit, this is the release pipeline. All right. In my release pipeline, these are I'm asking before starting my release pipeline, download these certain artifacts. What are these artifacts? First of all, this is the GitHub repository. All right. And I think this is also, I don't know why I'm using these two. You can simply ignore one. All right. Now, once you do that, and then this check, this is very important. I'll tell you what happens. In the architecture, I said after successful completion of DevOps pipeline, the basic build pipeline, it will automatically trigger the release pipeline. The way it works is I'm using this artifact. On this artifact, once my build pipeline is successful. So if you see, I have enabled it. If I disable it, it will here to here. This trigger will not be automatic. It will become manual. So I have already put it to enabled. That means this trigger to build pipeline to release pipeline is being done automatically. Now I'll go to, and when I'm saying when you will trigger release pipeline, you do these jobs and tasks. I've asked, okay, agent pool, you use the self-hosted agent pool. So this is my self-hosted agent pool. So Chet Consulting pool, right? It's not Microsoft hosted one. Now, when you do that, you perform a Helm upgrade command. Where you will perform? You will perform in the Kubernetes cluster. Which Kubernetes cluster? Inside this subscription, inside this resource group. This is my Kubernetes cluster, right? This is my Kubernetes cluster. This guy. All right. Yeah. I think this is not the good color. Yeah. All right. It looks good now. So this is my Azure Kubernetes cluster. I'm asking when you, as part of your release pipeline task, you simply use Helm upgrade command and deploy it to the Kubernetes cluster. Which namespace? I said for this particular session, I'm using retail-dev, right? If you go here, I said retail-dev. I'll say namespace. Okay. It will be more descriptive. Yeah. Okay. Now, and command you will use upgrade command. There is install command, upgrade command. Upgrade command is being used when you already redeploying existing deployment. All right. However, image name I'm overriding the image.tag value, which is this value, which is, if you go here, you will see this tag value. So remember, this will be ignored because I'm overriding that value. I'm overriding that value with the build number. All right. So I'm just use this build number and deploy it to my Kubernetes cluster. All right. Now I have to command my Helm from which portion of my source files, which file is the values.yml. So I will go here. I have browse file, so you will get this. So this is my build. In the another artifact I shown you, okay, just ignore this. Don't ignore this. This is my build file, actual build file. I think we're not using it because we're only using GitHub. So I'm asking this guy, go to Helm and use this values.yml file, this one, which is specifically dedicated for dev environment. All right, I'll cancel it. And I've tick mark install if my releases not present. So let's say if you want to create another job here, right? You will click one here, and then you will get another so many task recommendation. You will go and just Google around, okay, whatever task you need, you can just put in that task as part of your release pipeline. We only have a Helm upgrade, so we will simply use Helm upgrade. All right. So this is the very basic release pipeline. So we understood this DevOps pipeline. We understood this container registry. We also gone through the release pipeline. Now we will try doing a deployment. Okay. We will also talk about Postgres. So I'll go to I've already deployed AZ functions DB right here. Okay. So this database I'm using, this is the flexible Postgres server managed by Azure itself. Now we have gone through our cluster. If you see, I have already provisioned a cluster, urban tech details. Yeah, this is the same cluster, which if you see, this is the cluster, right? Urban tech details, and then this is urban tech details. So this is in running state. Now, okay, I think I left something here. So what I'll do, I'll create a virtual machine here. All right. So I'll say virtual machine. So this virtual machine is my use for self-hosted agent. All right. So I'll say copy this self-hosted agent. Okay. So this is being used by this DevOps subsystem. Okay. And what is this? This is, I'll also write agent pool. All right. So this is my agent pool. Okay. This is my agent pool. All right. So this is the architecture. Now we talked about this. We also talked about database quickly. Now let's start my agent, right? So how will I start my agent? I'll go to, in my last video I've already shown you, there is a dedicated video for self-hosted agents. However, that is in the Hindi language. If you guys want, I can make one in the English language. So I'll go to virtual machines. I'll start this. I think this is already running. I just have to start using it from my local. How can I access this? So what I'll do is, and remember I said my Kubernetes cluster is a private Kubernetes cluster. It's not a public Kubernetes cluster. That means only devices that are connected to my virtual network, retail solution VNet, right? In my last video I already spoke about it. So let's say, if you see, this is deployed on virtual network, retail solution VNet. Okay, now if you go to my Kubernetes service, you will see in the networking, in the virtual network, this guy is also connected to this retail solution VNet. So this is a private cluster. Only you can only access within VNet if your device is connected to your VNet. However, the agent which is running inside a VM, that VM is already deployed on the same VNet. So my VM can access this Kubernetes cluster, right? So in order to connect with the Kubernetes cluster, I will have to, in this machine, okay, so what I'll do is, I'll show you how to connect, right? In my last video, I already explained you how to connect with it. So I'll use SSH command, basic SSH command, right? So I'll put it here, and so these are the SSH commands, right? I need a public key, so my public key is here, self-hosted. All right. Okay, so I'm inside my VM. Now what I'll do is, I'll see, okay, I'll go back to my DevOps pipeline, and in order to see my agents, let's go to my agent pipeline, go to agent pools. You see there, these agent pools are already defined. This is the one I'm using in my pipeline, so Chet Consulting pool. Go to agents, you will see my agent is online. Why? Because I already ran it before making this video, and this is running in background. So run.sh, you see this is running. So what I'll do, for a moment I'll kill it. I'll kill 2101 process. Okay, so in some time my agent will go offline, then we will put it to online again, and then we'll start doing all the things. All right, so now what I'll do, I'll go to my DevOps pipeline again. I'll create another tab, otherwise I'll keep moving here and there. So I'll go to my consulting project, go to my pipeline, and then I'll run this pipeline again. Okay. So this is not updated. It will take some time because yesterday also it was taking some time to go offline, at least in this UI. So if you see, this task cannot be run because this is pointing to Suchet Consulting pool. So because my agent is down, my agent is offline state. You see, waiting for agent to receive and acknowledge the request. Now because of the fact my agent is not running, this pipeline cannot proceed further. So now I will simply go and cancel this pipeline. Okay, it will take some time, but anyways, so I have cancelled this one. Okay, build was cancelled. All right, so you see I have cancelled it, so my agent has gone to offline state now. So I'll put it to online state again. How can I do that? In my yesterday video, I already shown you how to create an agent, right, in VM. So here are my agent files. I will run it. I will run this. How will I run this? I'll run this agent.sh. All right. So my agent is up now. It has started listening on for jobs. So you see my agent is online again. Okay, now I'll go back to my pipeline here. So there is no pipeline at this moment. Now what I'll do is I'll go to my source code, because now we have to trigger a CI/CD. I need to make a change in the source code, and this whole process should get started, right? I, as an actor, I want to check in something right here in the main branch, and the moment I'll check in, this whole cycle will get triggered. This is the main objective of this video. Now I will open my IntelliJ. I'll go here. In my controller, I will simply say, I'll use SLF4j, and I'll say log.info inside get users API IDs. Alright, I'll simply print IDs here. So this is the change as a part of my story I'm doing. But however, it's very small change. In your stories, you might have very big business requirements. Now I'll go here in the commit section. I'll go here and I'll do a change here. So I'll say adding log lines at get user API. Alright, so I'll do a commit and push. So I'll do commit anyway, and I'll push it. So this change has been pushed. So if you'll go back to here and see, right? So adding log lines at get user 26 hours, right? This is the change. I have just done. So now this part I already did. Now this part should get triggered automatically. So I will have to go to my DevOps pipeline, which is the basic pipeline. So I'll go here. So you see, so I was inside the user pipeline already. So you see this pipeline has get triggered. So if you go inside it and go to first one, see pool, which pool it is using, this pool, which pool, this self-hosted pool, which is running inside my VM. Reason why I'm using a VM, I could have used my Mac computer as well. I could have used my Windows computer as well, my local computer as well. But I want this agent to be up and running all the time, so my developers can come to the office and start working and do all the DevOps stuffs, right? Now I'll go here. See, it said completed, succeeded. It was running a job. It completed the job. All right. So now let's go one by one. See, the Gradle command I said, okay, just do a Gradle clean build. So it did a Gradle clean build, all these things. See, all right. It said build successful. Then I said create a Docker image. You see, it has created a Docker image, right? All those things. Then this is very useless. Don't ignore it. And then when it created the Docker image, it basically has stored that image into my container registry. However, I can't see those logs here, but that's okay. So anyways, I'll go to my, where is that endpoint, Docker image. Okay. All right, I'll directly go to my Docker image, right? And then I'll go to my container registry, repositories, urban user service, this, right? See, today's date, just now, 14/13, right? So now this is the tag number it has created, the build number. This was the build number, right? Which basically build number is nothing but the today's date and .4, the version number. Now this is the Docker pull command, right? So means this part happened successfully. Now this part in the background was also, I don't know, we will go and see a release pipeline if it is successful or not. All right, so I'll go to my release pipeline. See, this was the build number 2024-04-14.4, right? This was my build number 2024-04.4. So this pipeline already ran and it was already successful by the time I am seeing this, right? So what I did is it downloaded all the artifacts we configured, if you see, right? And also after putting in all the artifacts here, it basically ran this command, help upgrade command. The command I basically configured, right? And see, this was the namespace I configured. It is using a stall command because of the fact it's the first time deployment. Otherwise, it might have been using. And then this is the value file. I don't know why I can't go here. Okay, so this is the value file it is using, and I said this is the image tag, use this image tag. All right, and then once it did that, it basically as part of the Helm, it also deployed the ingress, because if you remember in our Helm we also defined the ingress. So now my service can be accessed after this URL. All right. So interesting part is you might be seeing all these irrelevant names and file names, right, or the directory paths, right? Self-hosted agent. So these are the paths from where all these files, that the artifacts and that this guy, my agent, self-hosted agent, downloaded. This is the exact place where it downloaded. So if you can go to my VM, you will see all these things happening, right? So if let me just stop this agent, and if I go, I'm already inside home user self-hosted. So you will see this work directory. Did you see this work directory? All right. So if I go inside work directory, you will find all these things. So R1, okay, R1 and then A. I'll go inside A. I'll say okay, this artifact hyphen chet. I'll go inside it. See all these source files. So these are my source directories. Source directory, when I say, means your source code basically. So Azure YML all. So from here, from this position, my agent was taking all the file references. All right. So now let's go and try accessing this API from our Postman. All right. So I will use this. I already have this right here, right? So this is a get API, and then if you go to my IntelliJ, my controller was starting with -v1 and then get API users, and as part of query IDs, it's taking these IDs. So v1 -users and get, right? And then I have passed this particular ID. Now why this particular ID? In the middle of this video, I've shown you one database configured already. So using this dbeaver client, I can access my database from my client, right? I made it public. So, and then there is a table inside the retail DB. There is a user record table, right, which this guy is referring. So you see, if you go back to the project, and then if you go back to repository, where are my entities? All right, so you see this user record, inside which is schema, retail DB schema. So if you again go here, schema is retail DB, and then my table name is user record. So this is the content of user record. I have to pass an ID. So this is my reference, user ID. So I've taken one ID, I've taken this ID, Sagar ID. All right. So I'll go to my Postman, and then I'll pass this ID, and then I'll send hit button. So you see, I'm getting response. From where I'm getting response? I'm getting response from a service which is deployed here, So it's the moment when you hit this API, you hit that API from here, right? That's the ingress. See, that's the ingress. And then from here, this call went to pod, right? And then from pod, this call went to database. And then this guy received all the data values from the database, sent it back to ingress, and sent it back to this Postman collection. All right. So now, if you want to see the logs, because remember I made a change in the logs. So let's go and check the logs. So, but yeah, I don't know if maybe there might be a question, right? Remember, why I'm able to access this API from my local, it's my local computer. This part I skipped this part, I actually missed that part to explain you. So reason, this is my private cluster, so I cannot access it within my local computer. I have to take my local computer to that VNet, the VNet on which my private cluster has been deployed. One way of doing it is connecting to my virtual network using VPN gateway. So that's what I have done. So you see, this is the virtual VPN gateway. I'm connected to my VPN gateway. You see, I'm disconnected. I'll connect it. All right. So now from my local computer as well, it's connected. I can can use this, right? Now if I disconnect this, it's taking some time, but that's okay. Yeah, it's disconnected now. I cannot now access my Kubernetes cluster from my local computer. It will basically time out, right? But you don't need that because this ingress is public IP, so you can access it from anywhere, right? But you will need that if you want to port forward your services to your local computer. We will do that activity in some other video, but that was an added thing I wanted to explain. See, it went time out. All right. So now, this is done already, but I want to see the logs. I want to look at the logs. So so how can I look at the logs? So I will have to connect because I have to look the logs of this pod, right? That's how I'm able to understand if my request is being hit to my service or not. So let me connect to my Azure gateway. Okay, it's connected. So I can access these pods. Where is my user service? Yeah, this service. So what I'll do is I'll say kubectl logs hyphen. See, inside get user IP address, this and this was another log. It was in the service. So if you go inside service, I made another entry looking for records. It was already exist. It was already written already. Now, so this was the whole activity. All right. See, so that means my user service was successful for this API operation. Now there is another thing. I know video has gone longer already, but let's discuss one thing that we left from this architecture. You see, this small guy, we left it out, right? Database secret. So let's also check where is my database secret. So if you go here and then you'll see secrets. You will see this DB secret. All right, and then if you see get scribe secret DB secret, you will get all the values. All right. So however, I will not display the values because that's not correct because the video is going to be public. It has my username and password. So, but here you can see that we already have these database username and password, right? From here, my application is differing. How my application is differing? Very interesting. Go back to your templates. Go back to your helpers.tpl. So I've already defined some variable. I've defined, if you see in the Spring Boot, the way your application access the Postgres is because you are Spring JPA. You are using Spring JPA. You will have to define Spring database URL, Spring database username, password. So, although because of the fact I'm not passing the values directly, right, and that is the reason I'm referring this value from which secret? DB secret. So use which field, which key I have to use? I have to use URL. I have to use username. I have to use password. All these things I have defined already in my secret. Now how this? So you see, this is my retail DevOps directory. Inside this directory, I have URL, username, and password. This is where I have defined my database secret values. Now I'll put it down, and then I'll quickly tell you how I have deployed these username and password. If you go my pipelines, you will see this retail DevOps pipeline. All right, in this pipeline I have only defined deploying all my secrets. So if you go and you look at Azure pipelines.yml, this is also my repository. I want to deploy it, so everything needs to be deployed. Nothing has to be very manual, right? So what I'll do is I have created a different repository which only has my different aspects of DevOps. As part of that different aspect of DevOps, I have this database secret deployment. So it's all using Suchet consulting pool. Has different tasks. Which task? This task, right? Into this Kubernetes cluster, to this namespace, use the kubectl apply command and then deploy this database secret.yml file. Which file? This file. All right. So it's very simple. Then I have deployed multiple different things, Zookeeper and then Kubernetes Ingress. Ingress also I'm deploying the same way. So from which file? I already had the deploy manifest file. Which file? See this file. All right. Although I have not created this file, you can get this file from Bitnami, Helm, charts, or from Google. There are many resources, right? And then this is the basic secret file. All right. So that's how I have deployed this small guy, this guy. All right, guys. So I believe that we have covered almost all the things that we have spoken in this architecture. And if there is anything that I'm missing in this architecture, you can comment it out. I can create another video series, because video has already gone very long, like 1 hour 10 minutes. So probably I'll create another video. If there is any feedback or anything that you want to be added here, I'll create another video. Just comment it down. If you want, there is a specific topic you want me to create a video, just comment it down. I'll create a video. All right, guys. Thank you so much.